Why do we say that humans will never reach the edge of the universe? This question isn't as thrilling or sensational as asking whether aliens exist, nor does it spark imaginative wonder like asking whether we can travel through black holes. Instead, it feels like a question buried deep beneath the river of time, quiet, hidden, but heavy enough to shatter all our technological fantasies. When we gaze toward the edge of the universe, we may have to accept a sobering truth. No matter how advanced our technology becomes in the future, we may never reach the end of the cosmos. This isn't some pessimistic exaggeration. It's the cold, hard answer offered by the laws of physics. Before asking whether we can reach the edge of the universe, we first need to ask, does the universe even have an edge? Intuitively, people tend to imagine the universe as a giant container, like a balloon filled with stars, galaxies, and all matter. And its edge is just the surface of that balloon. But modern cosmology offers an answer that completely defies our intuition. The universe may very well be boundless, and yet finite at the same time. According to Einstein's general theory of relativity and later cosmological models, scientists found that the universe might be a finite but unbounded structure, like a three-dimensional space curved within a higher dimensional sphere. Just like the surface of Earth is finite but has no edge, you can walk in a straight line and eventually circle back to where you started. The universe might be the same, except in 4 dimensions. A finite surface, but with no physical boundary. That realization is the first shattering of our understanding of the universe's edge. It's not a physical endpoint, it's a mental illusion. The farthest region we can currently observe is called the observable universe. That's the part of the universe where light, traveling for 13.8 billion years, has just barely had enough time to reach us. But here's the twist. Because the universe is expanding, those galaxies that emitted light 13.8 billion years ago have now drifted much farther away. According to the Hubble constant, the radius of the observable universe is now estimated at around 46.5 billion light years. So the farthest we can see isn't 13.8 billion light years away, but 46.5 billion. This doesn't violate the speed of light limit, because it's space itself that's expanding, not light moving faster than it should. Think of 2 dots on a balloon surface. As you blow up the balloon, the dots move apart instantly, even though they're not moving on their own. So what happens if we keep going farther? What we see? Probably nothing. Not because it's empty out there, but because the light from those regions simply hasn't had time to reach us yet. In fact, that light may have left its galaxy long before Earth even formed, traveled through empty space, and then got stretched away by the universe's expansion, pulled so far it will never reach our eyes. So what we call the edge of the universe is really the edge of our perception, a transparent wall made of time and the speed of light. Maybe you're thinking, even if it's far, can't we just fly there slowly with spaceships? Theoretically, yes, but we still face a huge problem. The universe isn't static. It's expanding at an accelerating pace. Ever since 1998, when scientists discovered this through observations of type I supernovae, the physics community has been stunned. We once thought the universe would slow down after the Big Bang, perhaps even collapse back on itself. But the opposite is happening. It's expanding faster and faster. Scientists believe this is due to a mysterious substance called dark energy, which makes up about 68% of the total energy in the universe. We still don't know what it really is, but we do know it's real. And because of it, the expansion of the universe is not slowing down, it's speeding up. This means that galaxies more than 40 billion light years away are moving away from us faster than the speed of light. Yes, you heard that right, faster than light. But again, this doesn't violate relativity, because they're not moving through space. They're being carried away with space itself. So we get hit with another reality check. The edge of the universe isn't some fixed location. It's a retreating horizon, accelerating away. A finish line we can never reach. Even if we ignore space expansion for a moment, we're still limited by technology. Currently, the fastest spacecraft humans have ever built is NASA's Parker Solar Probe, which, when slingshot around the sun, can travel at about 430,000 miles per hour, roughly 0.064% the speed of light. Even at full speed, we're only doing 6,000ths of light speed. Now, imagine we somehow build a spacecraft that can travel at the speed of light. It would still take 46.5 billion years to reach the edge of the observable universe. But by then, that edge will have moved even farther away. Or let's say we send a sub-light speed craft, maybe at 10% the speed of light. It would take 10 years to go 1 light year, and 10 billion years to go 1 billion light years. In that time, the universe will have changed beyond recognition, possibly even reached its ultimate fate, heat death. And who's going to pilot this ship? A human? A human lifespan over 100 years is already a miracle. Will we rely on cryogenic sleep? AI robots? Sure, in theory, but each solution comes with immense ethical, technical, and resource challenges. Speaking of heat death, that's an even more depressing answer. The universe has a lifespan. According to the second law of thermodynamics, every system tends toward increased entropy until everything is in thermal equilibrium. The universe is no exception, unless some unknown physics intervenes, or energy is injected from outside the system. The universe will eventually become a cold, dark, lifeless void. Scientists estimate this will happen in about a googol years. That's the number 1 followed by 100 zeros. By then, stars will have all burned out, black holes will evaporate, matter will fall apart, and only thin, cold radiation near absolute zero will remain. Before that, within tens of billions of years, our Milky Way will collide with the Andromeda Galaxy, and the Sun will expand into a red giant and swallow Earth. If we want to survive in the universe, we must escape not just the solar system, but keep moving, fleeing dying galaxies. And if we haven't even left the solar system, how can we talk about reaching the end of the universe? In truth, the greatest boundary in the universe isn't space. It's not time either. It's our own understanding. Our brains evolved on Earth scale. We grasp sunrises, seasons, mountains, and oceans. But when faced with billions of light years, cosmic foam, or the multiverse, we are like ants staring at a computer. We can sense the outer casing, but never understand the system within. Physicist Hermann Weyl once said, "The most incomprehensible thing about the universe is that it is comprehensible." But comprehension isn't the same as arrival. You can understand that a circle has no edge, but you can still walk forever and never reach its end. The universe might be a mystery we know exists, but can never touch. So if the universe has no end, or if we'll never reach it, why are we so obsessed with trying? Maybe that's what makes us human. We're a species that looks up at the stars. We seek meaning in the void and belonging in the unknown. We may never reach the edge of the universe, but we can always push the edge of our awareness, even if just by a millimeter, even if just a little. Like when Galileo first pointed a telescope at the night sky, or Hubble captured those faint lights in deep space, or the James Webb Telescope glimpsed light from 13 billion years ago. Each gaze into the cosmos is a journey of the soul. Maybe the true edge of the universe isn't 46.5 billion light years away. Maybe it's inside us, as long as we choose to explore, to question, to keep our eyes open to the unknown. Human civilization will always move toward the edge, not by spaceship, not by engine, but by thought. And it is this thought that makes us, in this dark ocean of stars, the only species ever to ask, where is the edge of the universe?